Look in the mirror. If your eyes are green, you belong to a strikingly small group. Only about 2% of people on Earth have them. The rarest of the eye colors scientists consider common. But here's what makes green eyes stranger than blue. Researchers cannot point to a single ancestor, a single mutation, or a single moment when your eye color began. There's no green-eyed patient zero, and that's not a gap in the research. Green eyes may never have had just one beginning at all. To understand why, you first have to understand what green eyes actually are, because there is no green pigment inside your iris, and there never has been. Brown eyes are rich with a dark pigment called melanin. Blue eyes have almost none. Green sits in an oddly narrow gap between the two, not dark enough for brown, not empty enough for blue. That gap is one of the hardest targets in human genetics to hit. Drift to one side, and you get hazel. Drift to the other, and you get blue-gray. Green is a needle's width of biology, which is part of why so few people land inside it. Here's how that needle gets threaded. The iris has a clear outer layer called the stroma, sitting in front of a dark pigmented backing. Pack the stroma with melanin, and light gets absorbed. The eye looks brown. Leave it nearly empty, and light passes through and scatters instead. Shorter wavelengths bouncing back out toward you. That's a blue eye. No pigment, just scattered light, the same optical effect that turns a clear daytime sky blue. Green adds one more ingredient. Alongside a trace of brown melanin, the stroma carries a pale yellow pigment scientists call lipochrome, sitting on top of that same blue scattering. Take the yellow away, and you're left with blue. Add more melanin, and you tip into hazel. Green survives only in the narrow space where melanin, lipochrome, and scattering all hold steady together. Now push that biology back into deep time. The gene controlling how much melanin the iris produces is called OCA2. Beside it sits a regulatory switch called HERC2, which controls OCA2's activity. Ancient DNA shows the HERC2 version linked to lighter eyes was already common among European hunter-gatherers more than 10,000 years ago, long before farming reached the continent. But hunter-gatherers alone don't explain green eyes. Close to 8,000 years ago, farmers arrived from Anatolia carrying a different mix of pigmentation genes. A few thousand years later, herders swept in from the steppe with yet another mix. For millennia, these three populations kept interbreeding across Europe, shuffling their genes together generation after generation. Green eyes needed more than one gene to line up correctly, and without knowing it, ancient Europe was running that exact experiment over and over across three formerly separate populations meeting for the first time. Here's the finding that surprises even geneticists who study this for a living. Blue eyes come down to a single genetic switch, flipped one way or the other, which is why forensic scientists can predict blue or brown eyes from DNA with well over 90% accuracy. Try that same test on green and hazel eyes, and accuracy drops to near 70%. That's not because researchers found fewer genes involved. It's because green eyes don't come from genes simply adding up. Studies of gene interactions show that HERC2 and a separate gene, TYRP1, work together in a way neither manages alone. Their combined effect on green eye color is larger than the sum of their parts. Green isn't a midpoint on a dial. It's specific genes having to communicate correctly at the same moment inside the same cell. So why would evolution keep such a fragile, easily disrupted trait around at all? Here the story turns genuinely strange. Ancient DNA has let scientists watch natural selection happen in real time, generation by generation. And across thousands of years in Europe, the genetic switch behind lighter eyes was being actively and strongly favored, not just drifting by chance. But when researchers isolated the specific variant that pushes an eye from blue toward green, that signature of selection disappeared. The blue eye variant was clearly being favored by something. The green eye variant, riding along nearby on the same stretch of DNA, shows no comparable sign of being chosen for its own sake. Scientists have proposed explanations for why lighter eyes spread at all. Mate preference in early European populations, migration patterns that concentrated certain gene combinations, or genes doing double duty, where the same machinery that lightens skin for vitamin D may simply lighten eyes as a side effect. None of it fully explains green specifically. The honest answer is that green eyes may just be a passenger, a side effect that hitched a ride on traits evolution was selecting for entirely different reasons. Whatever the cause, the map today tells its own story. Green eyes cluster most heavily in Ireland, Scotland, and the countries ringing the North and Baltic Seas, Iceland, the Netherlands, northern Germany, the same region where hunter-gatherer, farmer, and steppe ancestry mixed most thoroughly for the longest stretch of time. That overlap could be coincidence, but it fits the idea that green eyes needed exactly that kind of prolonged mixing to happen at all. Travel toward Africa or East Asia, and green eyes become vanishingly rare, not because melanin works differently there, but because those populations never ran the same multi-population experiment that Europe ran by accident over thousands of years. Which brings the story back to you. If you have green eyes, you're not carrying one inherited accident passed down a single family line. You're carrying an intersection of several, a piece from a population that stopped producing much melanin in its irises, a piece from a different lineage that added a trace of yellow pigment, and the ordinary improbable fact that somewhere in your ancestry, for thousands of years, people from separate founding populations kept meeting, kept marrying, kept having children, until purely by chance, all the right pieces landed in the same two eyes. There's no monument marking where the first green-eyed human was born because there wasn't one moment to mark. There were thousands of quiet, unremarkable ones instead. A hunter-gatherer's child marrying into a farming village, a farmer's descendant marrying a herder from the steppe, each one a small roll of the genetic dice repeated for centuries until the odds lined up. Blue eyes can be traced back to a single person. Green eyes can only be traced back to an entire, ongoing history of people refusing to stay apart. Look in the mirror, and that's what's looking back at you. Not an accident, but a convergence. The one eye color evolution never quite finished deciding how to make.